Alright, welcome to the solutions video for homework 3.7b, where we're going to work three more optimization problems for you. So with number 19a, we've got this, a problem that's a whole lot like our example problem, where we have the a box where we snip out the corners and then fold it into, an open box. And so we're trying to find the dimension of the square piece. So I called that S. So we're trying to find the length of S that will maximize the volume of the box. Okay, so this box is a square. It's 24 inches on each side, and so we've got to have two equations. Our volume equation is going to be the length times the width times the height. And each of these sides, after you snip out the corners, would be 24 minus 2s. And the book even gives you that. I think they use x, but 24 minus 2s. So let's say that's length, and then the width would be another 24 minus 2s, where on our problem we used different lengths of sides. And then the height, once you fold it, would be s. Alright, so that's the volume, and we only have one unknown here, so really we don't have to do a substitution at all. So let's FOIL this out and then distribute the S. So volume is going to be 24 times 24 is 576. And then we would have negative 2s times 24 plus another negative 2s times 24. So that would be 96. So minus 96s. And then negative 2s times negative 2s would be plus 4s squared. And then we'll multiply that by the s. So distributing that s, we would have 576s minus 96s squared plus 4s cubed. So now to maximize s, we will take the derivative, so that would be 576 minus 96 times 2 would be 192 plus 12s squared. And then we need to get the critical point, so we'll set that equal to 0. So I'm going to factor out a 12 out of each of these. All right, so 12 out of 576 would be 48, and then minus 16s, right, plus s squared equals 0. And I'm going to go ahead, it's easier for me to think about if I put the squared term first. So s squared minus 16s plus 48 equals 0. That's just me flipping this around. And now we can factor this. You could also use the quadratic formula if you don't want to bother factoring this. But it factors into minus 12 and minus 4, right? 12 times 4 is 48. 12 plus 4, 16. So we would have two answers here. S is equal to 4 and 12. Now, if it's 12, then the box completely goes away because you'd have 12 plus 12, 24. So that's an extraneous solution. So S is going to equal to 4 inches. All right. Okay, number 22. So that is in your book, this picture right here. And we want to know what length and width will give the rectangle an area that is maximum. So you're just trying to get what is x and what is y. So we need an equation for area. For a rectangle, area is just x times y. And then it already tells us y in terms of x. Y is equal to 6 minus x over 2. So I can substitute that in right here, and I would have area is x times 6 minus x over 2. So distributing that x, I would have 6x minus x squared over 2. And then I'll divide 2 into each one of the terms in the numerator, so that would be 3x minus 1/2 x squared. So finally I can take the derivative. That would be 3 minus 2 times 1/2 is 1, so 3 minus x, set the derivative equal to 0. So x is equal to 3. And then y is going to be, we're going to plug right into here, 6 minus 3 over 2. So y is equal to 3 halves. And you can even look at the drawing and tell that x was 3 here and y is 1.5. So I didn't give you a real tough one on that, but you do have to go through the process. And then finally, the most interesting problem is number 31. So 31 is this right here. And we have a rectangular package sent to a postal service, can have a maximum combined length and girth, and the girth is the perimeter of a cross section of 108 inches. Find the dimensions that will maximize volume. So the girth is going to be 4x, right? The girth is 1, 2, 3, 4. You follow just that red. So 4x plus y. And then the volume is going to be x times y. So that would be x squared y. So those are our two equations. Girth is 108, and that is equal to 4x plus y. Combined, not multiply, but plus y. And then our volume equation is x squared times y. And we're trying to maximize volume. So we can pretty easily here solve for y. Y is equal to 108 minus 4x. Right, if I just bring that 4x over to the left, and then I can plug right there. So volume is equal to x squared times 108 minus 4x. So let's distribute the x squared. That would be 108 x squared minus 4x cubed. So here we could go ahead, I think, and we can go ahead and take the derivative. I don't think we need to factor anything out here. So v prime is going to be 216x minus 12x squared. Set that equal to 0. So we could factor out a 12x, because if you look at your calculator, 12 is a factor of 216. 216 divided by 12 is 18. So we could factor out a 12, factor 12x, and I would have 18 minus x equals 0. So we have two solutions here that make this 0. X is equal to 0. I don't think that's a solution, because if x was 0, you wouldn't have a package at all. And also 18. Okay, so we have the value for x, and then we can get the value for y. It's going to be 108 minus 4 times 18. And that would be 36 inches. All right. So that does it for this solutions video, and I will talk to you on the next lecture.